friend wrote a comment recently on an article on the website with a good question about the difference between modern mathematics and ancient or classical mathematics. I'm not going to get into the details of this discussion because they'd lead to a discussion that would require a lot of knowledge, a lot of background knowledge of the actual sciences themselves. And so what I'm going to do is answer this question briefly, but in a way that I think will be very helpful, because the difference between the studies has a lot more to do with the purpose of the studies than with the content of the studies. The content is different because the purpose is different. So let's start with modern mathematics. When we talk about modern mathematics, we're talking about modern arithmetic, modern geometry, and then school subjects like trigonometry, pre-calculus, and calculus. That's usually where the study of modern mathematics ends. If we look at these studies and ask, what's the purpose of these studies? Why do we start teaching children in kindergarten the math facts, addition, subtraction, multiplication, division, fractions, decimals, and so on? Why do we teach children these lessons? And the clear reason is because they have practical applications that are necessary to be understood. We really can't function in daily activities, certainly not in business, if we don't understand these operations, these different rules and principles. And so, because there's quite a bit to learn in these sciences, at least for arithmetic, we get the kids started early in these studies, and they continue through, in the modern school system, they continue through their middle school years when things shift. But everything from kindergarten through 6th or 7th grade, as far as mathematics are concerned, can be referred to as simple arithmetic. We're learning how to perform calculations in order to solve problems, to find answers to questions in practical matters, with practical applications. When I was a kid, I appreciated mathematics because I played sports. I can remember that I would be playing baseball and I'd get a hit, and let's say I got to second base, and I would stand at second base, and while I was standing on second base, I would quickly calculate my batting average. I'd say, oh, well, I came into the game and I was batting .346, and now I'm 2 for 3. So I know how many at-bats I've had and how many hits I've had, so I can calculate and get a good idea what my batting average is right now. And then if I was pitching, I would say, oh, I lit up 2 runs today, pitched 6 innings, so now my ERA is such and such, and I could quickly calculate my batting average, my ERA, and all these other kinds of sports statistics. In basketball, I could keep tab on my free throw percentage or my 3-point shooting percentage. And so I was always interested in modern arithmetic because of sports. And my father owned race cars. And so I had lots of applications for arithmetic growing up, and I was always working with numbers in ways that are probably pretty rare for most kids, but that's why I was good in math as a young student. Once I got to algebra, however, 7th grade, I had a teacher who just never explained to us what the heck the purpose of this study was. And I was just lost. I went from being a student who loved arithmetic to a student who just felt lost. I had no idea what we were even talking about. I felt like you just have to memorize what the teacher says, repeat the operations, and give back the answer, even though I had no idea what it meant. And so for me, algebra was the end of my interest in modern mathematics, because the practical purpose for arithmetic that I enjoyed, when I got to algebra, the purpose was just never communicated. And so I didn't understand the purpose, nor did most of my classmates. The kids who got good grades were the kids who didn't even care. They just did what they were told, turned in their assignments, and got good grades. Then in 10th grade, I studied geometry, and I had no problem understanding the purpose of geometry, and I got straight A's all through geometry. Junior year, it was trigonometry, pre-calculus. I had no clue what we were doing. And then senior year, we went back to Algebra 2, and again, no clue. Lucky I could get through the classes. And that was my experience in high school with modern mathematics. Arithmetic was awesome. Geometry was great. Algebra, forget it. I just didn't know what we were doing. When I went to college, we always had the option to take science classes that were designed for either students with algebra skills or the advanced science courses, advanced physics courses for students who had studied calculus. So I was always limited in what I could pursue because of that background I had in modern math, which just lost me. Now fast forward 30 years, where I'm actually teaching my own children and publishing curriculum and working as a school administrator, and I have the opportunity to revisit all these old subjects, revisit these modern mathematics subjects. And in the algebra classes, for example, in the Classical Liberal Arts Academy, everything's taught so clearly. And this is not to my credit, but this is just to the credit of the textbooks that we recover and restore and make accessible to the kids. The lessons are taught so well that I can see that if this was explained to me when I was in 7th grade, I would have had no trouble at all. For example, the purpose of algebra is to move from the specific problem-solving operations of arithmetic to generalizations or formulas that allow us to use the principles of the operations in ways that can be applied to a number of different specific problems. It's generalized arithmetic. Very simple to understand the purpose. The example that I always give was on our farm, which is one of the best places to learn mathematics because there's just so many direct applications. We had to manage the operation of our family dairy. And so we had to buy feed, we had to buy hay, we had cows to take care of and feed every day, we had to collect milk. The milk all had to be tracked and weighed. We had to figure out prices of what we should charge per gallon for milk. There's all this mathematical work that needs to be done, and it's impossible to manage that work by arithmetic. So it quickly becomes obvious that in order to track our costs of feed and hay, the amount of milk we're collecting, the amount of milk we're selling, the price per gallon, and making sure that in the end, when all the calculations are complete, that we're maintaining at least some profit. The only way that that system can be designed and managed profitably is by the use of algebra to figure out a formula for that whole business, where there's all different variables that can be changed. And we set this up in an Excel spreadsheet, and if the price of feed changed, we could change the price in that cell. If the amount of milk went up or down, we could adjust the quantities in those cells, and then we could adjust the prices that we charge customers in another cell, and just watch the final result, the profit cell, change as the variables were changed. And so it was very clear to see how in business, algebra is crucial to developing and maintaining a profitable operation. We can see how algebra works. And then when we get into higher maths like trigonometry and calculus, we simply move into different fields and different studies where, just as business management requires algebra, so other fields and other work require the advantages that are offered by calculus, for example. To study modern natural physics, the science of calculus was necessary and was developed for the sake of the study of physics as a tool. And so we can see that in all of the modern mathematical sciences, the purpose that they serve is practical. There's some practical objective that needs to be pursued, and the modern mathematical science is the tool that allows us to execute that objective. Modern mathematics have a practical purpose. So remember that. Modern mathematics, all of them, serve practical ends, practical purposes. Now, when we go back to ancient mathematics, and we talk about the ancient Egyptians, the ancient Sumerians, the ancient Greeks, with philosophers like Pythagoras, we find that when they looked at mathematics, they weren't primarily concerned, and I say primarily, they weren't primarily concerned with practical applications. Now, because the great writers of the ancient world don't write about practical mathematical operations, we falsely assume that they were ignorant of them. But that's not true. They did business. They were engaged in trade between different countries. They had to calculate the values of different currencies. They were sailing across seas and using celestial navigation. They were using mathematics in a million different applications. But that wasn't the subject of the writings. The writings were published by the philosophers. And when the philosophers talked about mathematics, they were talking about something very different. The purpose of the philosophical mathematics, or theoretical mathematics, was something different. And so I want to make it clear that ancient mathematics included practical applications, but that simply wasn't the focus writings of the great philosophers. They weren't talking about how to manage business or how to balance the budget of a city. They were writing philosophically. They had a different purpose in their writing, and they saw mathematics as a means of accomplishing a different set of objectives, if we think about it in a different way. And this is the difference between practical modern mathematics, which include no theoretical studies as far as philosophical issues go, and ancient mathematics, which focused almost entirely in writing on theoretical applications. So when we look at the ancient mathematical sciences, we can look at Boethius's opening chapter of De Arithmetic, or On Arithmetic, and he explains that in ancient times, the greatest philosophers found that the greatest progress was made when philosophers pursued truth by means of what he called a quadrivium. And that's where this word quadrivium comes from. It comes from Boethius' introduction to the art of arithmetic. And he introduces this quadrivium, this four-piece tool, as it were, this four-part method that's necessary for the investigation of true philosophy, or what he called true philosophizing. And this was considered the Pythagorean method, study of the world, of God, and of all things created by God, both visible and invisible, by means of mathematical arts. The goal for a philosopher was to move or progress over time from an examination of the world through the senses to an examination of the world by reason alone. And so the goal of philosophy was for a man to begin studying using his first set of tools, which are his own senses, and then finding a way to ascend from the world of physical objects that are sensible to the world of spiritual realities that are physically insensible but may be discovered by reason. And this ascent from sense to reason, or from physical to spiritual, material to immaterial, was the ascent of philosophy, was wisdom. And what did this have to do with mathematics? Well, you have to consider what options the philosophers had to pursue wisdom. Spiritual things, they argued, are in and of themselves unknowable. We can't study it. For example, we can't study God. God is an invisible spirit. He's unknowable. It's impossible for us, even as the Catechism teaches today, it's impossible for us to say anything with any certainty about God according to his true nature. He simply transcends all human sense and understanding. We cannot know God, and that's why in the first chapter of the Gospel of John, we read, "No man has seen God at any time." No man has seen God. No man can see God. So the question was, how can we get to spiritual things if there's no way for us to investigate them? No way for us to know them. They're unknowable. One answer would be, well, we could study the things that are sensible. And by the knowledge of the things that are sensible, maybe we could learn about that which is insensible. And so the philosophers studied natural philosophy. They studied the natural world. They studied bodies and physical objects through natural philosophy. And while we can learn about the things that are made, we can learn about the effects. We cannot know much about the cause. We can't know much about the creator from the things that are created. And so natural philosophy was found to have some help, to offer some help, but not enough. And so the question was, what could we possibly study that would serve as a bridge between physical things and spiritual things? Where can we find this ladder, as it were, between earth and heaven that we could climb and obtain wisdom? And what the ancients, and Pythagoras most famously, taught was that the ladder between the physical and the spiritual was the study of things that are called mathematicals. And a great place to read a little bit about this is in the opening chapter, the introduction of Ptolemy's Almagest, which is the work on astronomy. There he talks about these three different kinds of things: the physical things, the spiritual things, and then the mathematical things. And mathematical things are unique because they participate in both the physical and the spiritual. They're present in physical things, and yet at the same time, they can be understood without physical things. For example, we can see the roof of a house, and we can see the angle of the house, and we can see that a house has sort of a triangular shape, at least the top of it. We can look and see different things on earth in different shapes. We can talk about the virtues of the different shapes and the unique characteristics and nature of different shapes and how they relate to one another, how it affects their motion and behavior. And we can draw principles from visible things, from the mathematical characteristics of physical things, but then we can abstract those things and understand them separated or abstracted from those physical things. And that process of moving from the physical to the abstract, which is the peculiar virtue of mathematical studies, is the purpose of ancient mathematics. Ancient mathematics allow us to move from the realm of senses and physical things, as it were, by a ladder, by abstraction, to spiritual or immaterial things. And that's why mathematics dominated ancient philosophy, because they were the means. Study of mathematics was the instrument. It was the path, what Boethius called Pythagoras' purer way, or purer rule. to progress to wisdom. And so, if we think about this, and forgive me if I start to get philosophical and talk about any subjects you haven't had the chance to study, I'll try to keep things clear. But if you study Aristotle's categories, where Aristotle seeks to classify ideas or things that may be spoken of different subjects, different qualities, and he separates substance as the first category from 9 others. And the second of the categories is quantity. And it's in quantity that we find the mathematical sciences. The study of quantity is the study of ancient mathematics, because quantity divides into 2 basic divisions, or species. The first species is multitude, where a quantity is composed of a number of discrete or separate units. That makes for a quantity, a multitude. And the second species of quantity is magnitude, where we have a thing that may be increased or diminished, which is the essential quality of a quantity, but in a different way than a multitude. A multitude is diminished and increased in number of the units contained in the multitude. A magnitude increases and is diminished not in number, but in size, greater and lesser. And so this is the distinction of the 2 kinds, the 2 species of quantity. We have multitude and magnitude. And when we investigate multitude, we find that multitude divides into 2 species. The first species is absolute multitude, which we would consider to be number in modern talk. And the second species of multitude is relative multitude, or ratios. Absolute multitude, or number, refers everything to 1, whereas relative multitude refers to some other number. So, for example, the ratio 3 to 4 would be a relative multitude, whereas the number 6 would be an absolute multitude. Number has to do with absolute multitude. Ratio has to do with relative multitude. The study of absolute multitude was called arithmetic. The study of relative multitude is called music, because music is the study, if we think about the practical application, if you take an ancient flute or an ancient harp or lyre, what produced the different sounds and harmonies was varying the lengths, the distances between the holes in the flute, or the lengths of string on a harp. And so the ratios were seen as the source of the different sounds and harmonies, and that's why the study of ratio was called music. And arithmetic was the study of, as I said, absolute multitude. Now, the other species of quantity was magnitude. And when we investigate magnitude, we find 2 species. We find magnitudes that are at rest, which is considered a simpler form of magnitude. Magnitudes at rest. And then we have magnitudes that are in motion. And these were found to be the 2 species of magnitude. And so the investigation of magnitudes at rest was called geometry, because it related or applied to the study and measurement of the earth, which was assumed to be at rest according to classical astronomy. And the study of magnitude in motion was applied to the study of the heavens and therefore called astronomy, since the heavens were assumed to be in motion, according again to the ancient astronomy. And that brings us to the four ancient mathematical sciences: arithmetic, music, geometry, and astronomy. Now, what's confusing when we talk about these things is that the modern schools have retained these same names, but they haven't retained their meaning, and therefore talking about them carelessly is called equivocation, where we continue to use the same words, but the ideas that the words symbolize are not the same. And that's one of the reasons why education is confusing today, because modern schools have rejected the ideas but retained the names, and that causes confusion. So we still have arithmetic in school, and we still have geometry in school, and music is almost exclusively limited to actual musical performance, and astronomy has been redefined as the scientific or experimental study of the physical heavens. The original goal of the ancient mathematics has been abandoned. We're no longer studying mathematical objects as a means of ascending from the sensible world to the invisible world, because the spirit of the modern age denies that any spiritual world exists. When we deny at the very foundation of our philosophy or worldview, when we deny that God exists, when we deny that angels and spirits exist, when we deny that there are any effects in the world that have spiritual or immaterial causes, we deny that, and we replace that ancient understanding and philosophy with a modern naturalist philosophy that denies the existence of any supernatural forces and believes that every effect in the natural world has a natural cause that can be discovered through natural, physical, sensible experimentation. All of our studies no longer aim at helping man ascend from the sensible world to the invisible world. And this is, to finally answer the question, this is the difference between modern mathematics and ancient mathematics. If we go back to the ancient philosophers, to Pythagoras and the Egyptians and Plato and Socrates and Aristotle, they have something in common. And what they have in common is that they all believe in the existence of the supernatural world, of angels and spirits and gods. They believe the world is created by an infinite, eternal, spiritual being. That was taken for granted. They all believe that man is composed of body and soul. Aristotle writes explicitly a treatise called On the Soul. Aristotle believed in the invisible world. It was not even questioned. It was taken for granted. Plato in First Alcibiades, the very first dialogue we studied, seeks to establish the answer to the question, what is man? When we studied the Catholic Catechism, the old Baltimore Catechism, the first questions we learn, why did God make us? We ask and learn what separates us from the other animals. And it's that God created us in his own image. We learn this in the very first chapters of sacred scripture, that God created us unlike plants, unlike the fish and the birds and the beasts. He created us differently. He created us in his own image. He breathed into our nostrils the breath of life, and we became living souls, it says in Genesis. Man is composed of body and soul, made to the image and likeness of God. That understanding of man, as simple, as basic as it is not accepted in modern education. The curriculum of a modern school does not serve such a creature. The curriculum of the modern school, no matter what anyone says, the curriculum of the modern school is a curriculum for a beast. It's a curriculum for a physical creature. It does not acknowledge the existence of a soul. It does not acknowledge the existence of a creator. Even if Christian schools attempt to awkwardly tack on some kind of shallow and clumsy creationist additions to the curriculum itself, the subjects of the curriculum, the purpose of the curriculum, does not serve creatures made in the image and likeness of God. It serves some creature who's merely another species of animal. Again, no Christians will deny this explicitly or admit this explicitly. They'll all claim that they're seeking to glorify God in their schools. They're seeking to raise kids who will influence the world for Christ. They all have the same mottos and mission statements. But when we look at the actual curriculum in the school, we find a fulfillment of what St. Paul warned about in the New Testament. He said they profess with their lips to know God, but by their deeds they deny him. And this is what we find to be true of modern education. In a secular school, it's just understood. There's no religion, no spiritual talk, no talk of souls, heaven or hell. There's no such talk in a secular school. We're animals. We were formed by evolutionary forces. We just happen to be here. And it's understood that it's in our best interest if we all find a way to get along so we can all live prosperously for as long as possible. That's the mission of life in the modern secular school. That's why we have abortion. That's why we have contraception. That's why we have no respect for marriage, why we have promiscuity and fornication, homosexuality, on and on and on. Once we accept the idea that we're just another species of animal, and we establish some basic natural laws or political rules to set the boundaries for what we're allowed to do, we're really just living like an advanced species of animal. And that's what modern education is for. It's for this evolved ape who happens to be living in the state we're living in today. But if we were to go to the scriptures or to the catechism of the church, and ask, what is man? And then look at the modern curriculum, we'd say, how is that creature defined in the catechism? How is that creature to be educated by this curriculum? All of its subjects are aimed at temporal, practical ends. Where is the man's soul ever attended to? Where does man ever make the ascent from sensible things which pertain to his body to the superior things of human nature which pertain to his soul, which endure forever? Where is that part of the curriculum? And whether we're in a Christian school, a Catholic home school, when we look at the curriculum, the subjects of that curriculum are not appropriate for a man created in the image and likeness of God. To know, love, and serve God in this world and to be happy with Him forever in the next. We don't find that curriculum in the modern school or in the modern homeschool. As I said, this is seen nowhere more clearly than in mathematics, where the ancient purpose of mathematics is completely removed from the education, and children study mathematics only so far as they serve some physical, practical application. That's the difference between ancient and modern mathematics, and that's true of arithmetic, geometry, music, and astronomy. Now, if you'd like to talk about these individual sciences more, I recommend you just study the subjects. In the Classical Liberal Arts Academy, sign up for classical arithmetic. These things aren't mysteries. They're just not studied. Study classical arithmetic. Sign up for and study classical geometry. And you'll see what we're talking about. Go and read Plato's dialogues or Aristotle's philosophical works on the heavens and on the soul, and see how Aristotle moves by means of mathematical meditations from knowledge of physical things to knowledge of spiritual things. See how he actually uses mathematics. See how Plato uses mathematics as a ladder to move from earth to heaven. That's when you'll understand the difference. My advice to you, though, is to not stand outside the classical liberal arts wondering what's inside, but to go inside and study and learn. If Christians would give the classical liberal arts and classical philosophy a chance, they wouldn't be able to imagine life without them, never again. Unfortunately for me, there's no way for me to prove the value of these studies to people who will not study them. And that's what has, I believe, that's what has Catholic education paralyzed today. Catholic education can't advance because everyone has followed modern education down this dead-end road. And when someone says, we need to turn back because the path we took is false, he just gets looked at like he's crazy. And no one is willing to even give it a chance. And the reason for that is beyond me. I can't understand why Catholics are so timid. I can't understand why Catholics would rather die with this modern philosophy than abandon it. I can't understand why Catholics would just assume that the saints and wise men of the past were foolish and ignorant, and that the wisdom that they enjoyed is inferior to the errors and unhappiness and bad fruits of modern education and culture. I can't understand it, but the only way that we'll ever begin to make progress, like C.S. Lewis said, is to go back to the right road. But at this point in education and learning and culture, the only way for us to move forward is to take time to go back. To go back along the wrong road, back to that intersection where we wandered off course, and to get back on the right road, and to pick up where the saints and wise men of the past left off. So that's it. The difference between ancient mathematics and modern mathematics, as I said, is found in the purpose of the two different systems. Ancient mathematics were intended to be a means by which man ascended from the world of sensible things to the world of invisible things, insensible things. Modern mathematics are merely the study of operations and principles that serve practical applications. I hope that's helpful. If you have any questions or would like to talk about this more, please get in touch. I'd love to talk about it. God bless.